Welcome back to chemistry. My name is Mr. Kubuske. We've been talking about stoichiometry and mole-to-mole ratios, and basically we found out that we can go from one type of a substance, whether it's grams, moles, molecules, whatever it may be, and actually convert that information to a different substance and its grams, moles, or molecules, just based on a chemical reaction and that mole-to-mole ratio using coefficients, and that's basically what stoichiometry is. Today we're going to take it a step further. We're going to talk about something called limiting reactants, okay? And limiting reactants do exactly what they sound like they do. They limit the amount of product that we can produce, okay? Let me give you an example of what I mean. Let's say I'm a car manufacturer, and I'm just talking about I'm not talking about like Chevys and stuff like that. I'm talking about like handmade, like $250,000 like Ferrari, Lamborghini type cars, like really nice cars, okay? So I'm not going to make very many of them, but they're going to be really expensive, okay? So I've got 16 tires and I have 4 completed car bodies. So how many cars can I complete and roll off the assembly line that day? Well, if I have 16 tires and 4 bodies, I can make 4 cars. That makes sense, okay? But what if, let's say, I was a little lazy and I didn't get as much done this week as I was supposed to. I had my 16 tires that got shipped in, but I only finished 2 bodies. Well, how many cars can I make? Well, I have 16 tires, so I should be able to make 4 cars, but the problem is I only have 2 bodies. So the number of bodies that I have limits the amount of cars that I can make, and therefore I can only make 2 cars, even though I have 16 tires. So I'm going to have an excess of 8 tires left over that I'm going to need to use on cars in the future. But so far, the bodies that I've made have limited how many cars I can produce. And therefore my car bodies would be the limiting reactant, okay? So a limiting reactant is the element or molecule or compound or whatever you happen to be talking about that is completely used up during a reaction. And it also limits or determines the amount of how much of the other reactant is used and how much product is created. For example, I had 2 car bodies. That was my limiting reactant. So I can only use 8 tires and I only made 2 cars. So my other reactant was my tires and my product was the cars that I made. Okay? So the car bodies were the limiting reactant. And then the other thing, the tires then, since I have an excess of them left over, we call those the excess reactants. So they're going to be left over, okay? So the tires are the excess reactant. Now, there's going to be a very specific way I want you to do stoichiometry problems. We're going to put them into a table. I feel, and some of my colleagues feel, that it's a better way of organizing the ideas, the thoughts, and the numbers, so that way I can go back and pull them later on and use them in the questions that I get asked. Because these questions are just going to kind of build off one another. So as I go through here, you'll notice I have things highlighted, and the highlighted things will kind of go in the same column as I go. But what's written on the left-hand side over here where it says assume the tire is the limiting reactant, that's going to be this columns on the left there that's going to determine the questions that I ask. Okay, so let's say I have 298 tires and I have 102 car bodies. Okay, I want to know which one of these is going to be my limiting reactant. Which one is going to limit the number of cars that I can produce? Well, I don't know just off the top of my head. I actually have to do some math to calculate it. And what I'm going to do is I'm going to compare the number of cars that the tires can make to the number of cars that the bodies can make. So I'm going to do 2 problems. They're going to be exactly the same. I'm just going to use a different given to start with. Okay, so I'll show you what I mean. So I'm going to assume that the tires are the limiting reactant. If I do that, I start with 298 tires. So that's my given. So if I have tires on the left, I have to have tires on the bottom. Okay, and I know that there's 4 tires for every 1 car. I know that because of my reaction up here. 4 tires, 1 car. There's no coefficient, so that's a 1. Okay, so I cross out units and I would have just cars left over. So 298 divided by 4 gives me 74.5 cars. Now, so this number is directly linked to this number. So I draw an arrow from it over here to 74.5. Why do I put 74.5 over here? Because that's the number of cars that I can produce. So that's why that number goes over here. Now I'm going to do the exact same thing, but I'm going to do it with car bodies to determine how many cars I can make. Okay, so if I have 102 bodies, the bodies on the left, that means bodies goes on the right. So I need 1 car body, there's the coefficient here, so that's a 1, for every 1 car. So 102 times 2 divided by 1 is 102 cars. So that number is directly linked to that number, so those go together. So which one produces the least amount of cars? Is it the tires or is it the bodies? Well, obviously it's the tires. So the tires then are my limiting reactant, and I know my LR is covered up there, but I'm going to write LR up there to remind myself that that's limiting reactant. So since that's the limiting reactant, everything on this line right here is true. So I circle the true statement, and I'm going to drag down all the true information, the 298 tires and the 74.5 cars. And I'm going to round it to 74 because you can't make half of a car. Everything that's false, I want to get rid of. I'm going to cross it out. So if this wasn't a true statement, this is not the true limiting reactant, and this is not a true number because it's not. That's the excess. Okay. So I'm going to call my bodies the excess reactants. Okay. So now the only thing I need to figure out then is how many bodies did I actually use. Okay. I'm going to fill in this gap between the 298 and the 74 because that's going to be part of my ratio. For every 298 tires, I use a certain number of car bodies, which makes a certain number of cars. So 298, put 4 tires on the bottom. I put 1 body on the top because that's the reaction, 4 to 1. And I need 74.5 bodies, or just 74 bodies. Okay. The last thing that I'm going to do is I want to figure out how much leftover excess reactant I have. What's the leftover? So I started with 102 bodies. I only used 74. So I just subtract 102 and 74, and that gives me my leftover of 28 car bodies. Okay. So that's a practical, a real-world scenario of limiting reactants. But let's talk about it when it applies to actual chemicals in a chemical reaction. Now, this is the first problem of the packet that we're going to be working on. This is actually, it says example 2 because example 1 is the 2 separate problems. So if you want to follow along and add it to your table, again, the table that you have to fill in is going to be the table that I create right down here below. So let's start. We're going to assume that O2 is the limiting reactant. So I'm going to start with the given for O2. Okay, now I'm trying to figure out which one of these two, is it 5.55 moles or 2.45 moles of CS2? Which one of these is the limiting reactant? So I'm going to start with O2. So 5.55 is my given. If I have moles of O2 up here, I put moles of O2 down at the bottom. And I'm going to find one of the products. Usually, you're just going to do the first one in the chemical reaction. So I'm going to find how much CO2 I can produce from 5.55 moles of O2. So I'm going to put moles of CO2 on the top. Now I'm missing some numbers in the front. What numbers do I use? That's right, coefficients. So I put 3 on the bottom and 1 on the top because those are the coefficients. So 5.55 moles of O2 can make 1.85 moles of CO2. Okay, so I'm done with that part. I'm going to do the same exact problem. We're going to do it for the other reactant, for CS2. So I bring that down. I'm going to assume that CS2 is the limiting reactant, so I bring down to 2.45. That's my given now. So moles of CS2 will go on the bottom so it matches, and then I'm going to put moles of CO2 on the top. I do that problem, 2.45 times 1 divided by 1, and I get 2.45 moles of CO2. So CS2, I can produce 2.45 moles of CO2. O2, I can produce 1.85 moles of CO2. So which one's my limiting reactant? The one that produces least. Which one produces least? O2. So I circle that. I draw an arrow down to stoichiometric ratio. I write LR above O2 because that's my limiting reactant. I'm going to cross out all the false statements, okay, because CS2 is not the limiting reactant. It's the excess reactant. So I put an ER above it. Everything that is true so far that I've solved, I drag that down to the stoichiometric ratio. That's why I draw an arrow right here. And again, everything that I'm doing, I expect you to do on your table as well. So 5.55 moles and 1.85 moles. Now I need to fill in the gap here in the middle. How many moles of CS2 did I actually use? I had 2.45, but how much did I actually use? So I start with my moles of O2, limiting reactant, moles of O2 on the bottom, and my excess reactant will go on the top. So 5.55 divided by 3 will give me 1.85 moles of CS2. Last part of the problem, how much CS2 is left over? I had 2.45, I only used 1.85, I subtract the 2 and I get 0.6 moles. Okay? That is a limiting reactant problem in a nutshell. Again, you need to fill out the table correctly, make sure you do it in this way. Draw arrows, cross out false statements, circle the true statements. Okay? Use, when the problem is asked, use what the problem is starting with as the beginning of your reaction. If it says something like, based on the limiting reactant, calculate blah, 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 that means my given is going to be the moles of the limiting reactant. If the problem starts with grams and you have to convert it to moles, you'll need to do molar mass. If it gives you grams to start, you're going to divide by molar mass, because if grams is on the top left, that means grams has to be on the bottom right, and then moles would be on the top. So I'm going to divide by the grams. Okay? So again, read the questions carefully. There's going to be lots of questions, but each one of the questions is how we fill in this table. Looks like it's time to start class. I hope you learned something. If you have questions, go to the practice problems. Check the key. It's online. It's there for you as a resource. Make sure you use it as such. Don't just copy from it, but compare as you go. Don't just try to do the whole thing and then go back and look, because the problem is if I screw up one of these very first numbers, it could screw up the entire problem. Okay? So read what the question is asking for. Specifically, figure out what my what my given is going to be for the beginning of the problem and what I'm looking for, and then make sure you check your work as you go. If you have questions, contact me at jkubuske@gocathedral.com. Follow me on Twitter @Coach Kubuske, or visit the website mrkubuske.wordpress.com. Have a great day and stay warm out there.